Precalculus, Chapter 2A, Day 3, Synthetic Division. All right, now we're going to be dividing some polynomials by binomials. So here's a nice little example that we are going to start with. We are given the polynomial 6x cubed minus 25x squared plus 18x plus 9. And we want to divide it by x minus 3. So the question could be set up like this, because the fraction bar is division, right? So we need to be able to divide the polynomial by x minus 3. And there's a nice little algorithm that we call synthetic division, right? And you will walk through here. Let's walk through it together, even though it's all written out right above you. Okay? So because x minus 3 is a factor, okay, this is a term that we used earlier in 2a. That means that 3 is a 0 or an x-intercept, right? So because 3 is a 0, we are going to put 3 outside to divide with. Then we are going to place all of the coefficients from our polynomial. Okay, we're going to place them by themselves without any x's or x cubes or anything like that. Just going to space them out here. So it's 6, negative 25, positive 18, and positive 9. Okay, so we are going to spread them out just like that, right? I'm going to put a little line here. Okay, now here is the algorithm step by step. So after we have written the coefficients of the dividend in standard form just means that we have x cubed first and x squared plus that, and then x, and then the constant, and we don't have anything else on the other side of the equal sign. Okay, because we've done that, and we have maybe equals 0, like equals 0 here, right? We look at our 0, which in this case was 3, because we had x minus 3. If it had been x plus 3, we would have put a negative 3 out here, right? And now we are going to bring down the first coefficient. So that means we're going to take the 6, we're going to bring it straight down. Now, step 2, we multiply that first coefficient by our 0. So 3 times 6, right? And we get positive 18. Okay, notice that's what they have right there. So now we are going to add vertically. So negative 25 plus 18 is negative 7. That's where the negative 7 came. We repeat the process. 3 times negative 7, and we put the answer right there. So 3 times negative 7 is negative 21. We repeat the process by adding vertically. So 18 plus negative 21 is negative 3. Okay, notice that's exactly what they have here. One more time repeating the process. 3 times negative 3, put the product right here underneath the 9. So 3 times negative 3 is negative 9. We add, and here we get 0. Okay, now this is our remainder, right? As it says right there, remainder is 0. So what do we do with these numbers? These, just like the originals, are going to be coefficients of a polynomial. They're going to be coefficients of our reduced answer. So we took x cubed and we divided by x. So if you remember from Algebra 2, when you divide the same bases, you subtract top minus bottom. So your answer is going to have an x squared in it if you have x cubed and you divide by an x. So that means that we will translate this into 6, okay, instead of x squared, it's x cubed, minus 7, x to the first, minus 3. And then there's a 0 remainder. Okay? So with that, we can look at our example here. Use synthetic division to divide this polynomial by x minus 3. Okay? So we just did that. So our answer is 6x squared plus minus 7x minus 3. Okay? So this divided by this gives me that. Okay? So here is our quotient. It's our division answer. Okay? We started with an x cubed, we divided by x, we get an x squared. So we have a second degree polynomial when we divide a third degree by a first degree. Okay? So let's look at question 2. It says, it is known that x minus 2 is a factor, or it divides evenly into f of x, which is this nice big polynomial. Use synthetic division to do that dividing, and then keep factoring after that. And we want to then find the real zeros. So first thing we're going to do is we're going to say, my question is asking me to take x cubed minus 2x squared minus x plus 2. And we want to divide it by x minus 2. So keys here. X minus 2 is a factor. That means x minus 2 must equal 0. So that means that 2 is a 0. So if I'm going to divide this synthetic algorithm down here, I'm going to take 2, place it outside of my little division box. I'm going to look at my coefficients. My first coefficient, x cubed doesn't have one, so it's 1, invisible math. And then we've got a negative 2. We got a negative 1. We got a positive 2. Okay. So here we go. The algorithm for synthetic division. We bring our 1 down. 2 times 1 is 2. Put the 2 right there. Add vertically. Get 0. 2 times 0. We put your product right there. Add negative 1 plus 0. 2 times negative 1. Add, you got 0. Now, it's important to remember that if they say x minus 2 is a factor, then you must have a 0 remainder. It's like saying 5 is a factor of 20. So when I divide 20 by 5, I don't get a remainder. You have to get 0 for your remainder. Okay? So that's a good thing that we got 0 for the remainder. If I hadn't gotten 0 for my remainder, I'd have to go back and check my division, check my arithmetic, see what I got wrong. Okay, so we are going to now use our answer here to factor. So x cubed minus 2x squared minus x plus 2, okay, is going to be rewritten as, okay, we just said x minus 2 is a factor, but x minus 2 times what gives me that polynomial? Well, let's translate this. Okay. So this was x cubed. We divided it by x to the first. So that means that this right here indicates it's 1x squared, 0x minus 1. So we have x squared. I'm not going to write the plus 0x minus 1. Okay, this can be factored. Oh, yes, it can. It's 2 perfect squares with a subtraction symbol in between. So the difference of 2 perfect squares will give me, okay, let's take the square root of x squared. That's x times x. Square root of 1 is 1 times 1. since there's no middle term, it's got to be plus minus. This is a completely factored version of the polynomial that we had at the beginning. Okay? So x cubed minus 2x squared minus x plus 2 factored would be x minus 2 times x plus 1 times x minus 1. Okay? Now it asks me, what are the real zeros of f of x? So remember, zeros are x-intercepts. How do you find x-intercepts? You substitute 0 for your y. Okay, so if we say they equal 0, then, I mean, these are all factored out, so we can just split it. So x minus 2 could be 0, x plus 1 could be 0, x minus 1 could be 0. So my real zeros are 2, -1, and 1. So -1 and 1 and 2. Those are my real zeros. So if I put this in my graphing calculator, that polynomial graph would cross the x-axis in these 3 points. Okay? Or it would cross at -1, 1, and 2. Okay, we're halfway there. So number 3, it is known that x minus 1 is a factor of this polynomial. Use synthetic division. Okay, and then factor it again. So the same exact thing that we did before. Then they're going to ask us to state multiplicities, which we looked at in previous notes. So we're going to take x cubed minus 3x plus 2. We're going to synthetically divide it by x minus 1. So if it's x minus 1 for a factor, then positive 1 is the 0. Okay? So we already know that x minus 1 is a factor. Okay? So when we finish this, we better come out with a 0 remainder here. Okay, so x cubed is a 1 in front of the x cubed. Minus 3x, and then plus 2. Now, if we did this, we would not come out with the correct answer, believe it or not. The reason is, this polynomial is just a little bit different, okay? It's got an x cubed. It's got an x. It's got a 2. So the exponents are 3, 1, and 0 for the x's. If there are gaps, you have to fill them in with placeholders. So we would fill in this right here. So I'm going to put in my gap filler 0 here. And then we can put our -3 and our +2. Okay. Awesome. Okay, now let's do it. Bring the 1 down. 1 times 1, put it right there. Add. 1 times 1, put it right there. Add. 1 times -2, put it right there. And add. And yes, we do have a remainder of 0, which is good. So that tells me it used to be x cubed. So now this is 1x squared plus 1x minus 2. So we've got x squared plus x minus 2. Okay? But we want to factor completely. There's a quadratic here. Now we've got to go back to the product sum method of factoring. So let's bring our x minus 1 down. Okay. My product is -2. My sum is +1. Okay. So hopefully we can all figure out that that's going to be a +2 and a -1. They multiply to give me -2. They add to give me a +1. So I've got x plus 2, x minus 1. So part 1, factor it fully. It's factored. Part 2, what are the real zeros? So if I set this equal to 0, and you split it, you've got x minus 1 equals 0, you got x plus 2 equals 0, and you got x minus 1 equals 0. Oh, look at that. Cha-ching. Got zeros on my head. Okay. Well, what are the different zeros that we have? The real zeros are 1 and negative 2. Okay. Now it says, state the multiplicity of any repeating zeros. This one repeated. So 1 is twice, so it has a multiplicity of 2. Okay. Negative 2 has a multiplicity of 1, which we don't need to mention. So if we want to make an even better answer for the fully factored version, it would be x plus 2 times x minus 1 squared. Okay, so negative 2 is 1, 0, positive 1 with a multiplicity of 2 is the other 0. So if you graph this, you would see a negative 2, it crosses, the function crosses the x-axis, and a positive 1, because it's a multiplicity of 2, it bounces off the x-axis. Okay, our last one. All right, so do we have any gaps here? It's 1x cubed minus 6x squared plus 11x to the first minus 6. So x to the third, second, first, and 0. No gaps. Cool. Don't have to worry about that. X minus 1 is a factor, so 1 is a 0. All right, so we are going to take this lovely polynomial and we're going to factor it down. We already know that x minus 1 is a factor. Okay, so let's do our synthetic division. Bring your 1 down, multiply 1 times 1, add 1 times negative 5, add 1 times 6, add, again, remainder is 0, which is good because it told us that x minus 1 is a factor. So now, okay, I've got x squared minus 5x plus 6. Okay, let's fully factor f of x. Bring down our x minus 1. Okay, product sum. Okay, product sum. Product plus 6. Sum is minus 5. Okay, so two numbers that multiply to positive 6 but add to negative 5, that would be a minus 2 and a minus 3. So x minus 2, x minus 3. This is fully factored. There are no repeating zeros. They all have a multiplicity of 1. Excuse me, these are all factors, and they have the no repeating factors. So if we want these zeros, we could say x minus 1 is 0, so x is 1. X minus 2 could be 0, so x is 2. And x minus 3, 0, x is 3. Again, take your graphing calculator, graph this, and you'll see that your function crosses the x-axis at positive 1, positive 2, and positive 3. No bouncing, no flattening, all of them multiplicities of 1. Okay, so those are the real zeros. We've labeled everything. We are done. Day 3's in the books. Hope you enjoyed your synthetic division. See you.